We're going to be going over a problem from Free Response 2006. We're going to be doing A. I believe we're going to be doing B, C, and D. Okay, let's start off with problem A. Problem A is asking us from all the enthalpy values to determine the overall delta H. So they're asking us for the delta H of the total reaction. Well, we're looking here and we don't see any key words. We don't see our bond. We don't see little f. So we're going to be doing the reaction steps. Okay. So the reaction steps for the overall reaction are going to be the sum of delta H for the first reaction and delta H for the second. Referring to the values, we have the first being negative 110.5 kilojoules, actually kilojoules per mole, and the second being negative 393.5 kilojoules per mole. Okay, now I'm going to ask you guys to look at this at this reaction on your green packet. If you notice the first reaction, it's got carbon solid plus a half oxygen goes to carbon monoxide. Notice that the carbon monoxide is on the product side in that subreaction. And if you look at the overall reaction, the carbon monoxide is a reactant. Carbon monoxide is something that is specific to that subreaction. It doesn't show up anywhere else. So we're going to use that as our guide. In order to flip it over to the reactant side, we're just simply going to have to change the sign here. Now, we do not have to multiply that 110.5 by anything because the coefficient in front of carbon monoxide is 1 and it is 1 in the overall reaction. Moving to the second subreaction, the thing that reaction has unique to it is the carbon dioxide. If you notice, carbon dioxide is on the product side, excuse me, in the subreaction, and in the overall reaction, it is also on the product side. Again, the coefficient for each is 1. We do not need to change anything there. So simply, we add both of these up, and it's going to be a positive 110.5 plus a negative 393.5. So we can say 393.5 minus 110.5 equals, so we got a negative 283 kilojoules per mole. All right, that is our answer for delta H. Let's move on to B. B says, determine the value of the standard entropy change, delta S. Well, we're looking for delta S, and we don't have delta G yet. So we can't plug it into the God I hate this stuff equation because we don't have that. If you notice, they gave you some values for delta S. So in this case, let's assume we see a little f down there, and we're going to do products minus reactants. If you do this, we see that the value for CO2 is going to be 213.7. Okay, and the reactants, we have carbon monoxide and we have oxygen. Carbon monoxide is 197.7, and we have half an oxygen. Now, beware here, when we're dealing with delta H, oxygen is always going to be 0. But obviously, in this problem, delta S has a value. So again, use what they give you. If they don't give you a value for it, we know it's 0. If they give you a value, we're going to use it. Kind of beyond what I know about chemistry at this point. Okay, we're going to solve this answer for delta S. We're going to take 205.1, we're going to divide that in half. Using my ghetto superstar here, so bear with me, 197.7 equals that. And then we are going to subtract that from 213.7. So basically, 213.7 minus 300 equals. All right, so what we got here is a negative 86.3 joules per mole Kelvin. I want you guys to focus on this. Delta S showed up in joules, and everything else showed up in kilojoules. Kind of tricky. Let's go down here to C. It says determine delta G. All right, now we can go back up to our equation. Delta G equals delta H minus T delta S. Let's plug it in. Let's take everything now and convert it to kilojoules. Delta G equals 283 kilojoules per mole minus, yep, they gave you our temperature value, 298 Kelvin, multiplied by, now let's convert these joules to kilojoules. Let's move it to the left 3 places. So we're going to get 0.0863 kilojoules per mole Kelvin. You see the Kelvins cancel. So we're left with our overall units of kilojoules per mole. Not sure what this works out to. You guys can do the math on this. Not quite sure, but what I do know is the answer is going to be negative. So in question D, they do ask you, is the reaction spontaneous? And it is spontaneous because delta G is less than 0.